With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A cooling curve is plotted between temperature of a hot body and time. Now, which of the following is not true for the cooling curve? Okay. Now, cooling curve would be our dt divided by dt, where this capital T is the temperature, small t is our time. Okay. Now, how are basically these things related? Now, for example, Q, we can write our Q would be written as mc delta T, or we can say that our dq would be written as this mc into dt. Now, since it is a cooling curve, that means our dt would be negative. Okay. So to make our heat to be positive, we just introduce a negative sign. Okay, just to make our heat positive. Okay. Now, if we differentiate this expression with respect to time, then we can say that dq divided by dt, this would be equals to minus mc dt divided by dt. Okay, this would be our cooling rate. Now, C is our specific heat capacity, and we can write dq divided by dt as dt divided by dq divided by dt as q dot. Okay, this would be the rate of heat flow. Now, if this rate of heat flow or heat is lost due to conduction, then we can also write it to be equals to minus ka dt divided by dx. Okay, where k is the conductivity, a is the area, this is the temperature gradient. Now, if this heat loss is due to radiation, then similarly we can write it to be epsilon sigma a t to the power 4 minus ts to the power 4. Okay, where t is the temperature of the body at any instant of time, ts is the surrounding temperature, epsilon is the emissivity, sigma is the constant. Okay, a is the area. Now, in the first statement, what is given? Now, the cooling is faster from a calorimeter having a larger surface area. Okay, whether this statement is true or not? Yes, this statement is true. Now, this is our cooling rate. This is our cooling rate. So we can see that cooling rate would be proportional to area. Either from this expression we can see it is proportional to area, and also from this expression we can see that it would be proportional to area. So this is the correct statement, but we need to find the incorrect one. Now, second statement is cooling is faster for a calorimeter painted black from outside than for a polished surface. Okay. Now, if we are painting it black, okay. Now, if painting black means emissivity would be increased. Okay. So the maximum value of emissivity would be equals to 1. So if we are increasing emissivity, so cooling rate would be proportional to the emissivity. So if we are this cooling rate is proportional to emissivity, right? So if we are increasing emissivity, then dt divided by dt would be increased. That means cooling rate would be increased. So second is also a correct option, but we need to find the incorrect one. So this cannot be our answer. Now, in the third case, cooling is faster from a copper calorimeter than from a steel calorimeter. Okay. Now, first of all, we see that specific heat capacity C for copper, this is basically less than C for steel. Okay, we should know this, otherwise we cannot do it. Now, from the first expression, what we can write? The cooling rate. So from the first expression, we can say that our dt divided by dt, the cooling rate would be equals to minus q dot divided by mc. We can just write it like this if you put it to the other side. Now, if we are increasing C, then our cooling rate would be what? It would be decreasing. Why? Because these are inversely proportional. So if specific heat capacity for copper is less than specific heat capacity for steel, what does it mean about the cooling rate? So cooling rate is having the opposite nature. So dt divided by dt for the copper would be greater than dt divided by dt. That means the cooling rate for steel. This means that copper would be cool more faster. So our C statement is also correct statement, but we need to find the incorrect one. So this cannot be our answer. Now, the rate of cooling remains same throughout the experiment. No, this is wrong. Why? Because rate of cooling basically that would be changing. Okay, rate of cooling would not remain, because when the initially when the temperature value would be high, so this rate of cooling would be high, but after that it would decrease. So D is the incorrect one. That means the our option would be, because we need to find the not true option or the incorrect statement. So D would be the correct answer to this question. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.